And I shared okay, so I'm going to share the data set that I'm going to use for the hands-on exercise.
Okay.
So I can share the link
Yes.
to the Google Drive. So
Yeah.
maybe please check if you have access because I
Yeah.
set it to the anyone with the link can view it. Okay. So
Okay.
let me share the link here.
Thank you, Sue.
Uh-huh.
Maybe in the interest of time, we should get started, and I'll have Alex is going to get us started today. So let's see, Alex.
Sure. Yeah, so this is part of the iGuide VCO series. For anyone unaware, this is the virtual consulting office. So the idea is to have kind of a short talk and then a hands-on demo to learn about all the exciting work going on across geospatial data science. So today we're having an open source spatiotemporal geovisualization, geovisual analytics with CyberGIS, a COVID-19 case study. Next week, we're going to be talking about the iGuide platform for those interested in getting their hands dirty with that. The week after, July 16th, we have a talk on oldinsuраncemaps.net. So that's an interesting geospatial platform for georeferencing historical fire insurance maps. And he's going to also be talking about the software stack that's all open source there in case you want to build a platform of your own. July 23rd, we have From Fragmented to Findable, navigating the SDOH data landscape with integrated data discovery system. So SDOH there is spatial determinants of health. They're going to be looking at a platform for that type of data. And then July 30th, we have Jeff Boeing, who's going to be talking about the science of urban networks. If you're a Python nerd, that's the OSMNX package developer. So we have a lot of exciting stuff coming up. But yes, today we have former CyberGIS Student of the Year and current assistant professor at Texas State University, who's going to be talking about her ongoing CyberGIS-Vis work. So without further ado, go ahead.
Okay, so by the way, I was the student of the year in the CyberGIS group in 2011. So
I wasn't going to give away the date. I didn't want to age
You
you. I just
were the
wanted to.
first, I guess. Let's. Oh yeah.
So let me share the screen.
Yeah.
And then, okay. So can you see the first page? The first thing that I wanted to talk, I just share this slide and also the data set that we needed for the hands-on exercise. So yeah, please feel free to download this shapefile and CSV and PDF for this presentation. Okay, so I guess everyone can see the slide on the entire screen, right? Okay,
Yes.
so let me share. Okay, so let me start. So yeah, so this is about some geo-visual analytics or geo-visualization. So we are going to talk about some multiple linked views, coordinated views. So I will begin with an overview of the CyberGIS-Vis project. So they are co-authors. Actually, Alex is one of the co-authors of this work. And then I'm going to move on to the specific visualization modules, the spatial temporal modules that would be maybe focused today. And I also prepared some hands-on exercise using CyberGIS-X. So after maybe 20 to 25 minutes later, we will move on to the hands-on exercises. Okay. By the way, you can see the screen. Somehow I don't see the highlights of the screen. So
Yeah, I can see it.
okay, so let me talk about the CyberGIS-Vis project. So basically, CyberGIS-Vis, it provides the reusable, some reproducible modular visualization modules, which are made of some open source JavaScript or Python libraries. So I would say the CyberGIS-Vis is an umbrella project of or a visual analytics system that I have been developing. So they are the applications of the CyberGIS-Vis. And as you know, the geovisual analytics system normally consists of the interactive geographic part and computational method part. And for the interactive geographic visualization part, I have used visualization modules like a set of linked maps and charts that are available in CyberGIS-Vis. So this is the website for the CyberGIS-Vis, or the source code is available in this GitHub website. And actually, this is the paper that we published in the during the workshop on spatial computing for epidemiology at the ACM SIG Spatial Conference. Before maybe I go to the specific visualization modules, still I'm talking about the overview of the CyberGIS-Vis project, and I just wanted to introduce two visual analytics system that I have been developing. These are the titles of each system and the description and purpose of each system, and then computational method which run on the fly in the backend. But here the thing is, they can be used as a decision supporting tool that help policymakers or government officials to make a decision for like disaster management, response relief, healthcare, and urban planning, and many more. So in this presentation, I'm not going to talk about these decision supporting tools, but I'm going to only talk about the CyberGIS visualization modules, and among these modules, and I'm going to talk about only two modules, which is the spatiotemporal modules. Okay, so the CyberGIS-Vis is made of JavaScript-based state-of-the-art open source libraries. Basically, it brings the mapping functionality from the Leaflet and geographic, maybe graphing functionalities from these graphing libraries like D3 and Plotly, and make a linking to create the multiple linked views. So that's the CyberGIS-Vis. So let me give you a very brief overview of the CyberGIS-Vis. So CyberGIS-Vis provides the visualization modules for quantitative data as well as the categorical data. And it has been developed actually based on the principles of modularity, allowing users to select the visualization modules from a wide range of the data visualization techniques implemented in HTML or JavaScript. So it actually allows you to combine the maps and chart that you see on the screen in any way that you want. So they are like a visualization modules. So and the names. So in the CyberGIS-Vis project, so we first developed the adaptive choropleth mapper, so just ACM, so which is the choropleth mapping tools for mapping for multiple choropleth maps. And this is the base of the CyberGIS-Vis, and then various charts are linked to adaptive choropleth mapper for creating multiple linked views, just like what you see on the screen, maybe as an example. And also ACM for categorical data. Also, it also has the categorical data. It works in the same way. So, I just wanted to talk about, what makes the CyberGIS-Vis innovative. Here, the thing is, there are maybe CyberGIS-Vis provides some distinctive features that set it apart from other existing geovisualization and mapping tools. So I just tried a list here, but we have like 1 hour time limit, so I will only cover maybe 1 or 2 features here using the case study that I'm going to share from the next slide. So in this talk, okay, for the maybe today's visualization, so I'm going to cover only 2 visualization modules, so which are the spatiotemporal modules. And then I'm going to visualize this COVID-19 data and human mobility data in the US county level. So I would say that one of the key differences between the CyberGIS-Vis and other tools maybe used to visualize COVID-19 data during the pandemic is that CyberGIS-Vis is designed to be reusable and reproducible for future pandemics using data sets from other diseases. So maybe let me show you how it can be easily reused. So I have to talk about the maybe CyberGIS-X first, which is the platform where the CyberGIS-Vis runs. So CyberGIS-X is an online version of the Jupyter lab environment. So everybody can use it online. So once you create an account, so during the hands-on exercises, everybody will create an account and maybe then use it. So the CyberGIS-X is also, I would say, maybe similar to the Google Colab, but the CyberGIS is more maybe specialized to geospatial analysis. So actually, this is also very similar to iGuide platform. So as I understand it, the CyberGIS group initially developed the CyberGIS-X, which is now being enhanced to create the maybe iGuide platform. And then CyberGIS-Vis is not actually, the CyberGIS-Vis is not currently supported on the iGuide platform, but in the near future, so you will be able to run it in iGuide. But in the meantime, maybe today I will use the CyberGIS-X for today's hands-on exercises. So I would say the biggest advantage of using CyberGIS-X or iGuide maybe is that we do not need to manually install the Python packages, and which are often required when running Python code on your PC or in Google Colab. So I think maybe one of innovative features of the CyberGIS-X is the sharing feature. So let me show you how the sharing works. Like for example, this is my code of a CyberGIS-Vis on GitHub repository. And this is the Jupyter notebook that I would like to publish and share in the CyberGIS-X platform. Then you just go to the CyberGIS-X website and fill out the form, including maybe Git repository URL, and you specify the name of your notebook. And you publish, then this is how it looks like once you publish. So once this notebook is published like this, I mean, once the GitHub repository that you wanted to publish is published like this, and other users, other CyberGIS users can promptly use the same code and the same development environment by clicking this yellow button here. So actually this is where you can start by creating the visualization. So yeah, this is something that you are going to do during the hands-on exercise. So you just click the yellow button, then all the source code, it brings all the source code from the GitHub repository, and then maybe, and then you have this environment. So this is the Jupyter notebook where then you can start running. Okay, so what you are going to do just to run the create the spatial temporal visualization modules. So the first thing that you need to do is to set or enter the input data. So this is the Jupyter Lab environment. So you should enter the attribute data. So using the Python code, so which is pretty simple. And then you also should enter the geometry data. So here the thing is the key of attribute data and then geometry data should match. So yeah, it should match. And then second, you need to set the parameters. So once you run this function, then you are going to see the graphical user interface. Then you are going to set the parameters. Okay, so I'm going to maybe show you later after this presentation. The thing is, after you set the parameters, then you run it by clicking this green button. Then you are going to have your visual visualization. So after you run it, then so once it's done, then you are going to have this link. Then okay, this is for the visualization. and then maybe for the log to see all visualization that you created. And this is for just the advanced functions. So by the way, once you click the first link, then you are going to have this visualization. So the thing is, okay, I created this video. So this is how it looks like after you set the COVID-19 data set. But I just created this video to maybe effectively show you maybe all the functions of this visualization modules. So I guess this is maybe more efficient way than the live demo. So I will show you this video. This video is almost like 10 minutes, but so we will see.
In this video, I will demonstrate how to navigate and analyze weekly COVID-19 data for U.S. county.
By the way, can you hear the voice?
Yeah.
Okay. Okay. Let me play it again.
In this video, I will demonstrate how to navigate and analyze weekly COVID-19 data for U.S. counties using the CyberGIS-Vis Spatiotemporal Visualization module. The display includes 2 choropleth maps and a chart that shows the top or bottom values for the right map, along with multiple linked charts. Now let's begin with the adaptive choropleth mapper. At the top of each map, drop-down menus allow you to select from multiple variables to visualize. You can explore weekly COVID-19 confirmed rates, death rates, and cumulative totals for each, covering the period from March 2020 to November 2021. Now let's take a closer look at the current display. The left map shows the COVID-19 confirmed rate for the week of April 6, 2020, illustrating the early stage of the first wave of COVID-19. In contrast, the right map displays the confirmed rate for the week of July 20th, 2020, which represents the peak of the first wave. Now, let's talk about the classification method. There are several classification methods available to create class intervals for choropleth maps. In this case, I have selected the geometric progression classification method because it effectively represents the distribution of the selected variables. Now let's focus on the map legends. As you can see, the classification intervals for both maps were generated separately using the geometric progression method for each dataset, April 6th confirmed rate on the left and July 20th confirmed rate on the right. This results in different class intervals on each map. This approach is useful for examining relatively low and high confirmed values within each map, but it poses a challenge for direct comparison between the two maps since the class intervals are not consistent. To facilitate a direct comparison between the two maps, I'm going to apply the same class intervals using the Link All feature. When we select Link All and click the Submit button, the system consolidates the data from both maps and recalculates the classification intervals using the chosen classification method. In this case, geometric progression. This alignment ensures that both maps share identical class intervals, making it easier to compare them directly. One notable observation is the significant increase in the confirmed rate in California and a decrease in New York and its surrounding areas. To demonstrate this more clearly, I'll use the geocoding tool at the bottom of the maps. I'm going to enter New York City and press Enter, and the map will center on New York City. This time, I'll zoom out one level to view a broader region. Since we've enabled the Link All feature in the menu above, both maps will pan and zoom together. Let's examine the distribution pattern. There is a noticeable decrease in the confirmed rate on the map from July 20th on the right compared to the earlier date of April 6th on the left, especially throughout New York and the surrounding areas. Now, I'm going to demonstrate how the multiple linked charts work. I'll scroll down to display the entire visualization of the multiple linked charts. Each chart visualizes the following metrics for the selected region, New York City in this case, from March 2020 to November 2021. Weekly COVID-19 confirmed rate, death rate, cumulative confirmed rate, cumulative death rate. To view the selected location on the map, I'll scroll back up to see the maps again. Next, place your mouse cursor over the line chart area, and you'll notice that the selected region, New York City, is highlighted on the map with a cyan outline, just like what you see now. Let's examine how these charts are linked with the two maps. To demonstrate this linkage, I'll select the selection tool here on the map and click on a different area. For example, let's select Somerset, New Jersey. Notice how the charts update to show the weekly changes of the 4 variables for Somerset, New Jersey. Similarly, wherever you click on the map, the charts will visualize the weekly changes for that selected area. Now, I will return to New York City to show you some research insights. Let me scroll down again to display all the charts together. Now let's talk about another feature. One of the innovative functions of the multiple link charts is when you zoom into a particular time range, it redraws the Y value, which can reveal more detailed ups and downs of temporal changes. For example, in the case of confirmed rate, I now feel that I would like to see a small fluctuation of the COVID-19 infection in between the first and the second wave of the pandemic. To do this, you can zoom into that time period by clicking and dragging. Watch closely. Currently, the y-axis range is from 0 to 1500. Now I will click and drag the mouse from June 8th to the end of September to zoom in on this specific period. Then, as you can see, the y-axis value has been readjusted. Initially, y value ranged from 0 to 1500, but after the adjustment, it starts from 30 to 100. This allows for a more detailed observation of the temporal fluctuation within this new time period. Now I see the lowest drops on Aug 24th and highest on Sept 21st. These variations are not able to be observed before I zoom in to this specific period. To go back to the original view before the zoom in, you click this little blue button on the top right corner of the chart. Again, this is the area that I just zoomed in. The fluctuation cannot be seen very well unless I zoom in. Another powerful feature of the multiple link chart is its ability to synchronize across all charts when adjusting the time range on any one of them. If you zoom in on a specific period in any of the 4 charts, the others will automatically adjust to display the corresponding time series data for that selected period. To demonstrate this, I will zoom in and then reset the charts to their original state several times. Notice how when you zoom in, all charts align to show the data for that period. Likewise, when you reset to the initial state, all charts revert to the entire original time period that was initially set. Now let's move on to the bar chart. This bar chart represents the top 10 highest values for the selected variable. It's linked to the map on the right. As you change the variable in the drop-down box above the right map, the bar chart will display the top 10 values of the selected variable on the right map. For example, I will change the map layer on the right map to show the confirmed rate for the week of March 23rd, 2020. As soon as I change the layer, the right map visualizes the selected variable. At the same time, the top 10 bar chart updates to match the selected variable on the right map. Simply put, the right map and the top 10 bar chart always display the same variable. As you interact with the map by zooming in or panning, the bar chart dynamically updates to display the top 10 regions within the current map view. Please watch as I adjust the map. The bar chart will update in real time, reflecting the data for the newly selected area. This feature allows you to quickly visualize the most relevant information based on the current map extent. Now let's talk about the mouse hovering function of the bar chart. The right map and the bar chart are currently displaying COVID-19 confirmed rates for March 23rd, 2020 in New York and the surrounding areas. As you can see here, Fairfield, Connecticut had the highest confirmed rates. Please notice that when I hover over the bar representing Fairfield, Connecticut, this area is highlighted on the map. Take a moment to observe how the highlighted polygons appear on both maps. Next, I'll move my mouse cursor to the second largest bar, which represents Montgomery, Pennsylvania, with the second highest confirmed rates. Let's explore a few more bars. Pay close attention. As I hover over each bar, the corresponding county is highlighted on both maps simultaneously. This feature allows you to easily identify the geographic locations of counties with the highest confirmed rates. Additionally, you can use the drop-down menu at the top of the bar chart to adjust the number of top or bottom values displayed, such as 20 or 30, and even visualize the counties with the lowest values of the selected variable. Thank you for watching.
Okay, so let me move on. So this one, just I wanted to show you that you can visualize any data set that you have. So you can visualize any spatial temporal data set that you have using these visualization modules. So basically I utilize the same visualization modules, the multiple linked chart modules in CyberGIS-Vis, and now it shows the confirmed cases in vaccinated population at zip code at zip code level in San Diego County. So yeah, the key is that whatever the spatial temporal data you have, you can set your own data set for this visualization. So actually, and then another one is this is just another visualization. So maybe before, this is just a video, but so I prepared the two visualization, but maybe before before we watch this video, now I'd like to maybe
In this video,
maybe show you how to do it in the CyberGIS-X. So I think maybe everybody can try it. So okay, so this is the CyberGIS-X website. So in my case, so I have the account. So if you don't have the account, so actually you have to register first. So you can register using your institutional email. So actually most of people can register within maybe 3 minutes or something. So in this case, maybe you are going to see maybe register or login instead of this launch CyberGIS-X. So yeah, maybe let me see if I can see the initial screen without the logo. So I think what you can do, maybe I can use the different browser. Yeah, please register for the CyberGIS-X account. So in your case, maybe let's try my another browser because maybe CyberGIS-X and so go to CyberGIS-X. So you have to register. So register with this one and you click this one. And then, okay, so you have this, you just click continue to CAI log on, and then you change your university since I already have an account, so I don't need to do it again. So yeah, so you just do the maybe remember this selection and log on. Then you just enter your username, password. So this is my score. Maybe you will see the different page. Then I have to go through this authentication process. Yeah, please do it. Then I can wait maybe 3 minutes or something. And let me know when you're ready so that I can move on. Yeah, so after the registration is done, then you're going to see the Launch CyberGIS-X button instead of the register CI logon or something. Then you are pretty much ready to go. Okay, thank you, Joseph. Joseph is ready. Maybe I will wait for maybe 2 minutes more. By the way, if you happen to have the CyberGIS-X account, also please let me know. I just wanted to see how many of you already have an account. Caching is ready to go. I registered and see my profile, but the main page still offers register button instead of a launch. Maybe could you refresh? Still offers register button instead of launch. You see my profile button. So if you are registered, when you click the My Profile, then you should be able to see something similar to this. Refreshing didn't change. I am using Firefox. Actually, mine is okay in Firefox. Alex, do you have any ideas?
I'm not sure. Let me check the back end to see.
Mm-hmm.
What was the username or email you registered with? Okay, I'll check on the back end and see what's going wrong.
Yeah, SALEVY.
Yeah, we see you in the back end. It definitely has you as registered.
Okay. Yeah, he can now see the launch button.
Oh, okay. Weird. We'll have to look into what happened there.
Okay, so it worked for William, so thank you. And yeah, please let me know if you want me to wait a couple of minutes more. So if I don't hear anything, then I will move on to the next step. Yeah, since we are recording this, you can always, go back here and see. Okay? Yeah, okay, now I will move on. So, okay, so what we are going to do, what we are going to do, so let's go to the discovery. So do you remember in the PowerPoint slide, I said once I publish the notebook, everybody can have access to this environment, right? So that's what I'm going to do. The thing is, okay, so now just click the discovery, and then I'm going to find the published notebook. So maybe let's use the keyword CyberGIS-Vis. Okay, so this is the notebook that I'd like to use. All right, so I'm going to click this view notebook. Yeah, please everybody look at this notebook, and I'm going to click. So okay, so if you cannot find it, so you can have a direct access using this link. So I am sharing the URL where you can directly jump to this web page. And then I'm going to click the open with the CyberGIS. The thing is, by the way, this is the overview of the Jupyter notebook. So it looks like this. So the thing is, you cannot run it here, but once you click this open with the CyberGIS, then you are going to have an environment you can actually run this code. So this is the I'm just assuming that you are maybe familiar with the Jupyter Lab environment. So if not, no worry, because this is really simple. So yeah, let's click the open with the CyberGIS. Then it is basically pulling the my source code of the GitHub website onto this environment. So please wait. So so I believe I shared the so this is the GitHub website. So this is the GitHub website. The thing is, even without having access to this website, okay, so this is the GitHub website. I put the code here. So you don't even need to maybe look at this website because it's already automatically copied or the source code from this GitHub website. So these are the page that you can see now. Can you see the same page? Okay, so this is so let me close it to reduce the confusion. I'm going to close everything. So in your case, you click this one, or this button, then you are going to see the energy bar. Then this is the page that you can see. Okay, I know Xing is ready. Just let me know if you need any help or if you want me to repeat anything like that. Okay, then I'm just guessing everybody is ready to move on to the next step. So yeah, this is the Jupyter notebook. So when in the Jupyter notebook, you can run the each cell. So this is for like importing the libraries. The thing is, you don't need to install any Python packages. So what you are going to do is that you just run the first cell. So when it is loading, you are going to see an hourglass figure, and then I'm going to run the second cell. Oops. Okay, so if you have the same issue, so what you're going to do, you're going to restart the corner. Okay, restart the corner, then it will disappear. Okay. If you happen to have an expected error, just restart corner and try it again. So in your case, okay, so it's running. So I can see the hourglass figure on the top. So you can run the each cell by using this play button or by entering shift and enter. Now, so it's loading the shapefile of the area. So this shapefile, it's the county level. So it's the geo ID for each county and in the United States. And now it's loading the CSV file. It has the attribute like confirmed rate, death rate, the total, something like that. So you just load this input attribute data. Now next one is this one. So the thing is, so this is actually once you run it, so you are going to see the graphical user interface where you can enter the parameters to create the visualization. So the thing is, okay, let's run this cell. And you have this. Okay, now let's. Okay, so in this case, a lot of parameters are pre-filled already. So we just need to change a little bit. So input attributes, you just assign this variable where you assign your input data and also this variable. So I will just leave it as it is. So this is pre-filled. So when you use different data sets, so you have to enter your own title, and also this is the title for the chart. So after I create the visualization, maybe I'm going to show you where these titles are displayed. And then output for the name, I think this is also fine. So for the period, so for the maybe line chart, you can select some maybe some period. So in this case, I'm going to all. It means that it's going to visualize maybe all periods, the data for all periods in this second column. And then variables, maybe these variables actually are from this attribute, right? See, confirm death, total death, maybe this one. So it's the from the input. So I'm going to, maybe you click the control key to have the multiple selection. You press the control key and then select this. Maybe I'm going to visualize these 6 variables. And then numberable maps, the 2 are fine, but you can adjust to maybe 1 or 5. Yeah, just it's up to you, but the 2 are great. The sort layers, so just read it, and then you're going to enter temporal or compare. So in this case, temporal is fine. And then I'm going to visualize top 10 chart and multiple line chart. And then the number of chart, the line chart, it's same with the number of variables that you selected, or you can adjust, it's up to you. But I will just leave it as it is. For the default region, so let me, maybe let me select Miami. And then let's run. Okay, so now once it's ready, so you click the first link. Yeah, let me know if you have any questions so far. Okay, I don't see any questions, so I will click the first link. Okay, so this is the visualization. So in this case, it has confirmed the rate, death rate, maybe confirmed the rate, cumulative, confirmed the rate, and then the visitor, the number of visitors from the selected regions, and the number of visitor flows from the selected area. So yeah, so now you click this one, and then you can click wherever you want. And this one, you can change the date. So it's showing the maybe before pandemic and yeah, just at the beginning of the pandemic or the middle of the pandemic. Then you can set the same classification intervals, and you can see the New York is hotspot here, and then but New York is not hotspot here. Yeah, now it's more, maybe California has more confirmed rate. Yeah, so this is the so yeah, I already showed you the video, so I think you can revisit the video in terms of how to use this visualization. So but I just wanted to show you how to create this visualization. So the next one, then yeah, please let me know if you have any questions. Okay, so I don't see any questions. So let me move on to the next one. So it's the visualization using comparison line chart, which is also visualizing the spatial temporal data, but it's using the different charts. So I'm going to run. Okay, so yeah, so in this case, I will just leave it as it is. The title and then the chart title. Maybe in this case, yeah, this one you only pick only one variables, and then this one you want to check the compare, and then because in this case, maybe for the comparison of the temporal patterns of the two counties. I will enter New York and Miami. Yeah, but you can leave it empty, then the just default region will be visualized. So this one, I forgot to mention, this is the map center and also the zoom level. So if you're not sure of the map center and zoom level, then you just call it without parameters, then it's going to automatically identify the zoom level and the map center. So it doesn't have to be there. So I just wanted to let you know. So let me create the visualization. And now it's a different visualization. Okay, so this one actually, in terms of how to use, I inserted the video. So this video is pretty short. So let's watch the video in terms of how this visualization works. So, okay, so let me play this video.
In this video, I will demonstrate how to navigate and analyze data using the comparison.
I'm sorry.
In this video, I will demonstrate how to navigate and analyze data using the comparison line chart module available in CyberGIS-Vis. To start, hover your mouse over the chart area. Notice that on the left map, New York City is highlighted in cyan. The blue line on the chart represents the COVID-19 confirmed rate in New York City over time. Now let's shift our focus to the right map. Here, you can see King County in Washington State highlighted in cyan. The orange line on the chart shows the COVID-19 confirmed rate for King County over time. Next, we'll compare the temporal patterns of the confirmed rates between two different counties in California and Florida. First, I will zoom into California on the left map by typing California into the geocoding tool and pressing enter. I will do the same for Florida on the right map. Now, as you can see, both states are zoomed in. Next, let me show you how to visualize the temporal patterns of COVID-19 confirmed rates in regions of your choice. Start by clicking the selection tool on the map. On the left map, click on Los Angeles County in California. Once selected, you'll notice that the blue line on the chart updates to represent the temporal patterns of the confirmed rate for Los Angeles County. To compare this with another region, let's select Miami-Dade County in Florida on the right map. Upon selection, the orange line on the chart changes to display the temporal patterns of the confirmed rate for Miami-Dade County.
I'm sorry,
With these selections,
this area is hidden, so sorry, let me share it again. I don't know why that happens. Oops, no. Okay, let's.
In this video, I will demonstrate dates to represent the temporal pattern of the confirmed rate for Los Angeles County. To compare this with another region, let's select Miami-Dade County in Florida on the right map. Upon selection, the orange line on the chart changes to display the temporal patterns of the confirmed rate for Miami-Dade County. With these selections, you can now see a clear comparison of the temporal patterns of COVID-19 confirmed rates for the two selected regions. Let's examine the functions of the comparison line chart. This chart allows us to examine each temporal trend line individually. For example, you can examine the temporal line of Los Angeles or just Miami-Dade County, or you can compare both simultaneously by clicking the Both button here. Let me click the Trend Comparison button.
Sue,
Trend Comparison button
Yes?
allows you to compare trends of two
look at the.
regardless of.
Can you look at the chat? There are a couple of people having maybe a little bit problem.
Okay, so. Okay, the idea will be wrong. The page only displays a title. Oh. Okay.
Data
Let's
range.
see. Okay. I believe there is something like something that you should enable, because sometimes your browser just blocking loading this result. Okay, so because sometimes you see only the title and then submit button, but there's no maps. And then clicking to see, click the URL below. Because some cases, okay, okay, so by case, maybe this one or, yeah, it's related your browser settings. So you have to enable something that your JavaScript code, is loaded on your website. So it's also depending on the browser. On-call reference at a moment is not defined. So Alex, what browser are you using?
I'm in Firefox.
You're in Firefox. Then what about this? Can you try maybe go to the folder COVID-MLC, eSIM COVID-MLC, and then run, and then you click Trust HTML and see if it's loading. Because there's it's asking trust or distrust. There's another way that you can visualize your visualization. This one should work even without enabling something in your browser. Yeah, because Alex, the error that you are getting is because it doesn't have access to the JavaScript library. So your browser is blocking the JavaScript. Did anyone try this one? Because this is the folder where your visualization created. That you should be able to see the data folder and index HTML. Then you double click, and then you just click the trust HTML. And this is the another way that you can see your result. Does it work?
No, and I click trust, I still see a submit form. There may be like a data processing step that possibly we missed.
Oh, maybe. So, but I think all you need to do is just run. That's it.
Mm.
And then even, did you select the variables? You need
Yeah.
to select at least one.
Yeah, it gives you an error if you don't.
Yeah, I first got the submit form, but I just re-click on the HTML file. It will pop up. Just click and click. Yeah.
Okay, so
It works for me.
okay. Yeah, because my case, I can see you have granted this website additional permissions. So it's related to your browser setting. Let me try it in Google Chrome browser and see what's happening. Okay, so I can actually, this is the CyberGIS-Vis, and then click. Yeah, I think if I remember correctly, I had to click some buttons on somewhere here to enable, maybe, yeah, to enable something. Yeah, so that's related to your website setting. Okay, Joseph said I added an exception for the website in the Firefox and now it works. And Stuart, I'm not seeing the trust HTML option when I right click or double click on the, I see lots of other options like hit delete and shut down corner. Yeah, Joseph said you go to setting privacy and manage exceptions. Okay, so I think I spent an hour. So actually I had a plan to to upload the new data set and then visualize another data set using the same visualization modules. So, but I think the time is up, so I can just spend time to help out others. The trust agent button here is on the UI. Yep.
Yeah, just for anyone running into issues with where it is.
Mm-hmm. Okay, the trust HTML did not work for me. Okay, so yeah. Yeah, since I haven't got a chance to cover the hands-on exercises, what I'm going to do, so I will maybe take a screenshot. Maybe I will create another Jupyter notebook and showing you how to visualize this data set that I wanted to visualize. Then I think we can wrap up this with your talk. Or if anyone of you, I don't know, if anyone of you wants to stay, then I can maybe keep going, but I know we have like 1 hour limit.
Yeah, and so I guess if there is there are interest, when we can do one later where you can just focus on the things that we missed today. So we could do something like later that you could just.
Great.
Yeah. And I was having issues in Firefox, but I opened it in Chrome and it worked perfectly.
Oh, okay.
That might just be the solution.
Also, sometimes it depends on your browsers. Yeah, the version. Maybe it works in my version but doesn't work in your version in relation to the security.
Yeah, in Chrome, I had to enable like allow third-party cookies or something. So there is some setting which prevents.
Okay, so Joseph made it work.
Thank you.
Okay.
So maybe I think since we are at time, maybe we will officially wrap this up. And so if you are available for a little bit, we can stay along for a few more minutes. And then maybe if there is interest, we could do another VCO, which we could focus on the things Sue has yet to cover.
Yes.
Yeah. And yeah, thank you, Sue, again for doing this today.
Yeah, thank you so much. Then you can stop recording now.